All right. So today we are going to actually rewind a little bit and revisit an old topic, especially when we're solving equations with, you know, with two equations actually. Let's be more specific, which is what happens when how do you know if something has one solution, no solutions, or infinitely many solutions? Okay? All right. So let's take a look. Okay, all right. So here we go. All right. Let me speak a little bit louder. All right. So here's what we're going to talk about today. All right. One none or infinite solution. Now let's fast forward and rewind actually. Back in 2020, right? The last time we encountered this issue was this, right? By the way, this is a historical first. I'm officially use a screenshot from a video that I myself made before. All right, so history in the making here. So now, back in the day, right, when we were solving equations with variables on both sides, right, such as this, and at the end, when you subtract it and you realize that all you're left with is negative 10 equaling to negative 20, which is not true, right? That I said that would indicate that this equation, these two equations, have no solution, right? So that's what we had talked about months ago now. And at the same time, right? Because usually when you solve equations with variables on both sides, you would have one answer, right? And in this case here, we have no solution. And in this case, where both equations are the same, we have infinite many solutions. And I proved it to you right here. So these are infinite many solutions, right? And you guys had done the delta math work accordingly, right? So now that we're graphing, what does that look like? All right, that's the big question. So now that we're graphing, so I have three examples for you guys. So now that we're graphing, all right, here I got one line, right? So this is y equals to x plus 2. And here I got the other line, which is y equals to negative 3 halves x plus 2. And you will realize when these two lines intersect, there's your solution, right? So the solution here is 0, 2, right? 0, not going left or right, and I'm going up 2. So the solution here is 0, 2, right? So that's the first scenario, like the classic, you know, equation, solving an equation example, where you only have one answer. Here, let me present to you a second scenario, which is something like this, right? So this is my first line here on the left, which is y equals x plus 2. And the second one is where y equals x minus 1, right? Have you noticed, so if you were to graph both lines, you'll realize that these two lines, they're going the same direction and they're tilted the same way. So they're both slanted in the same angle, so to speak. So which means, right, if this line were to go forever and ever, why is this yellow? Oh, all right. If this line were to go forever and ever, like this, right, and the other line goes forever and forever like that, they will never, never, ever intersect or come across or cross paths with one another. All right. So in that case, all right, it's kind of like me and Katy Perry. All right. My favorite pop star. Right. It's kind of like me and Katy Perry. We're never going to cross paths. Okay. Very sad. All right. Now, what does this mean, right? This means then that there is no solution. Why? Because they don't cross paths, right? There's no common point, right? There's nothing in common, right? Okay, that makes me even more sad now that I say that. All right. So no solution, right? Now, one of the things I really want to, and we don't emphasize that in Algebra 1 anymore, but back in the day, teaching ninth grade algebra uh, course, is that we used to emphasize this. Now, let me ask you guys this, all right? Let me move this guy around a little bit. All right, here and here. What do you notice that's the same? Or what do these two equations have in common? Can you tell? It's a very tiny difference. What do you notice about these two equations that are in common? Now, there are a few things. I understand that, right? They both are in the slope-intercept form, but look closer at the slope-intercept form. What do you notice about the both of them? Look even closer at the variable x. What do you notice? Yeah, they're the same variables. They're the same slope. So in other words, let's use a blue pen. All right, in other words, both of these have a slope of 1. Therefore, they will never, ever cross paths. So we are saying that these two lines are therefore parallel. So what am I trying to say? When two lines have the same slope, I'm probably going to type something, edit something into this. I'll probably add a bubble here. All right. So what am I saying here? When two lines have the same slope, when two lines have the same slope, the two lines are parallel. They run parallel. That means they will have no solution. Okay? Is that clear? All right. Third scenario. All right. I really should erase all this stuff. It's getting in the way. All right. All right. Okay. So the third scenario here is here I got two equations. I got y equals to x plus 2 and negative 3x plus 3y equals 6. Now, you've already noticed, right, that these two lines, they're identical, meaning they have the same slope and the y-intercept. Now, some of you might say, well, Mr. Ring, that's not true. These aren't the same equations, right? But you'd be wrong. Why? Because if you convert this one into from standard form to slope-intercept form, it's the same equation. So what do you do, right? Because it's not that just that their slope is the same, right? So here you can say, well, Mr. Ring, the slope's the same, then why aren't they parallel? Here's the problem. The y-intercepts are different. I mean, are the same here, right? The y-intercepts here are different. So they're both at a different starting point. So even though they share the same slope, they would never touch, right? Whereas this line, they're the exact same equation, right? So of course it's gonna be the same line. So what do we say here? We say that they have infinitely, they have infinite solutions. So they share every single solution together. As you can see, the points here, and the points here. Okay, and that's today's lesson. So, man, that must be the shortest lesson ever. That was 8 minutes. Oh, all right. Okay, so come back to class. We'll just practice a few of these questions, and then let's see if we can start doing some word problems with these. Okay? All right. So come back to class right now.
OMG, that was so good.